Briquet presses are useful machines. They take waste materials and turn them into dense blocks. These blocks are called briquettes. You can use these briquettes as fuel. This is a good way to recycle things like sawdust, paper pulp, or agricultural waste. Instead of this stuff ending up in a landfill, it becomes a resource. This helps reduce overall waste. It also provides a low-cost alternative fuel source, which can be very handy. This is practical engineering at its best, solving a real-world problem with a straightforward approach that benefits both the user and the environment by diverting waste streams. The core of this DIY press is a lever system. A lever helps you multiply force. Think of a crowbar. A small effort at one end creates a big force at the other. For our briquet press, this is crucial. We need a lot of pressure to compact the waste material into a solid briquette. Without a good lever, you would need to be incredibly strong. The lever makes the job manageable for an average person. It's a simple machine doing heavy work, allowing you to apply significant compaction force without requiring excessive physical exertion. We specifically aim for a 10-to-1 mechanical advantage with our lever. This means for every 1 unit of force you apply to the handle, the press exerts 10 units of force on the material. This ratio is important. It provides enough force to properly compress most common waste materials into dense, usable briquettes. If the ratio is too low, the briquettes might be loose and fall apart. If it's too high, the lever might become too long and unwieldy or require too much travel. The 10-to-1 ratio strikes a good balance between force multiplication and practical usability for this type of manual operation. This entire briquette press design is fully manual. It does not require electricity or complex engines. This is a key feature. It means you can build it and use it almost anywhere. It also means fewer things can break down. The simplicity reduces manufacturing waste if you're building it from scratch. You are directly involved in the process of turning waste into something valuable. This hands-on approach is not just about making fuel. It's about understanding the transformation of materials and the power of simple mechanics, fostering a greater appreciation for resourcefulness and engineering principles. The piston and cylinder mechanism is the heart of the compression action. The cylinder is a strong tube that holds the wet waste material. The piston is a plunger that fits snugly inside this cylinder. When you operate the lever, it pushes the piston down into the cylinder. This action squeezes the material, forcing out excess water and compacting the solids together. The tighter the fit between the piston and cylinder, the more efficient the compression will be. This prevents material from squeezing back up past the piston, ensuring all force is directed into compaction. Adjustable pressure can be very helpful when dealing with different types of materials. Some materials like fine sawdust might compact easily with moderate pressure. Other materials such as shredded cardboard or coarser plant fibers might require more force to bind together properly. While this simple design might not have a complex pressure gauge, you can learn to adjust pressure by feel or by how much material you load. You can also modify the design slightly, perhaps by having different lengths of lever arms or by adjusting the initial volume of material to achieve varied compression for diverse feedstocks. For the frame of the press, you need something strong and rigid. Steel is a good choice. Angle iron or square tubing can be welded or bolted together to create a robust structure. It needs to withstand the forces generated by the lever without bending or breaking. For the piston, the shaft can be steel, and the piston head could be made from thick, dense plastic like HDPE, or even a very hard wood, shaped to fit the cylinder. The cylinder itself is often made from a section of heavy-gauge steel pipe, ensuring durability under repeated high-pressure applications. These materials are often available as scrap, reducing costs. Replaceable parts, especially for the molds or the cylinder base, are a smart addition. This allows you to make briquettes of different shapes and sizes. For example, you might want small round briquettes for a particular stove or larger square ones for longer burning. Having interchangeable mold components means your press is more versatile. If a part of the mold wears out, you can replace just that part instead of the whole assembly. This modularity extends the life of the press and makes it adaptable to different needs and materials over time. Recommended dimensions for the main parts will vary with your needs, but here are some general guidelines. A common cylinder diameter might be around 3 to 4 inches. The height of the cylinder could be about 8 to 12 inches. The lever arm providing the mechanical advantage should be significantly longer, aiming for that 10-to-1 ratio. For instance, if the distance from the lever pivot to the piston linkage is 4 inches, The handle length from the pivot should be at least 40 inches. The frame needs to be tall enough to accommodate the full travel of the lever and piston. Safety is paramount when building and using any machine, even a simple manual one. Incorporate a locking feature for the lever. This can prevent it from accidentally falling or swinging when not in use, or while loading material. Ensure the base of the press is wide and stable to prevent tipping during operation. All moving parts should have adequate clearance to avoid pinch points for your hands. Smooth any sharp edges on metal parts. These simple precautions can prevent unnecessary injuries and make the machine safer to operate for everyone who might use it. An ergonomic design makes the press more comfortable and efficient to use. The handle of the lever should be at a comfortable height. Consider adding a padded or wooden grip to the handle. This will make it easier to apply force repeatedly without causing discomfort or blisters on your hands. The loading area for the cylinder should be easily accessible. You don't want to be struggling to get the raw material into the press. Thinking about these human factors will result in a machine that is not just functional but also a pleasure to use regularly. To assemble this briquette press, you will need a few basic tools. If you are working with steel for the frame, a welder will be necessary for strong joints. A grinder will be useful for cutting metal parts and smoothing edges. You'll also need a drill for making bolt holes. A good set of wrenches and a measuring tape are essential for accurate assembly. Depending on your chosen materials, you might also need woodworking tools if you opt for a wooden piston head or handle. Having the right tools makes the job easier, safer, and ensures a better quality build for your press. Assembling the press involves a few key steps. First, construct the main frame. This will be the backbone of your machine, so ensure it is square and strong. Next, create the lever mechanism and attach it to the frame using a sturdy pivot point. Then, fabricate the piston and cylinder. The cylinder needs to be securely mounted to the frame, aligned directly under the piston. Finally, connect the piston to the lever arm. Double-check all connections, ensuring bolts are tight and moving parts operate smoothly without binding before you attempt to use it for the first time. Using the press is straightforward. Prepare your waste material. This often involves shredding it and mixing it with water to form a pliable pulp. The consistency is important. Too dry and it won't bind. Too wet and it will take forever to dry. Load this mixture into the cylinder. Then pull down on the lever. This action drives the piston into the cylinder, compressing the material and squeezing out excess water through drainage holes in the base of the cylinder. Release the lever, eject the compressed briquette, and set it aside to dry completely before use. To make your design even more sustainable, consider the materials you use for the press itself. Try to source recycled steel for the frame and other metal components. If you use wood, choose reclaimed wood. Think about the entire life cycle. Design the press for easy disassembly so that its parts can be recycled or repurposed at the end of its life. You could also share your design plans openly, allowing others to build their own, further promoting waste reduction and resourcefulness within communities. This holistic approach enhances the environmental benefits beyond just the briquettes. In conclusion, building a DIY lever briquette press is a practical project. It offers significant benefits. You can effectively recycle various waste materials, turning them into a useful fuel source. The design relies on simple engineering principles, making it accessible for those with basic skills. It's a fully manual operation, reducing reliance on external power. By following these guidelines, you can construct a robust, safe, and efficient machine. This not only helps manage waste, but also empowers you with a tangible way to contribute to a more sustainable way of living, one briquette at a time.